Welcome to the deep dive. Today, we're doing something a little different. We're focusing on just one source.
Yeah, just one, but it's a really significant one.
Absolutely. It's packed with ideas about the future, a future we're, all stepping into right now. Our goal here is to really unpack this one fascinating blog post. We want to pull out the key arguments, maybe some surprising claims, and the big implications the author's laying out.
Basically, try and give you a clear but still deep understanding of this particular take on artificial intelligence.
Sounds good. So what's the source?
Okay, so the source for this deep dive is a blog post called The Gentle Singularity. It's by Sam Altman, who's the CEO of OpenAI. Well, and it's pretty dense. It lays out his view on where AI is right now and where he thinks it's heading, like, really quickly.
Right.
So we'll dig into his main idea that the big shift has kind of already happened. We'll look at his timeline for what AI might do soon, his vision for like a future of abundance, and also, importantly, the big challenges he brings up, especially around safety, alignment.
Okay, great. Let's get into this perspective then. What might a gentle singularity actually look like, according to this piece? And maybe, what questions does it raise for all of us? So right off the bat, the post makes this pretty bold claim.
Yeah, doesn't pull any punches.
It says, we are past the event horizon for AI, and that the takeoff has started, which, sounds incredibly dramatic.
Hugely dramatic.
But then he immediately kind of contrasts that with, everyday reality. Like, there aren't robots walking down the street. We haven't cured all diseases. Getting to space is still really hard.
Right. It doesn't feel like that kind of takeoff has begun for most people.
So how does he square that? What does he mean by event horizon if it's not, obvious change?
Well, that's the interesting part. His definition. He's arguing it's not about the visible societal disruption yet. It's about the fundamental scientific breakthroughs. Oh. He believes the really hard part, the core scientific insights, the kind that led to things like GPT-4 and similar models, that part's done. It's behind us.
Okay. So the potential is unlocked, even if the effects aren't fully manifested everywhere.
Exactly. In his view, the core capability is there. He even says current systems are already smarter than people in many ways, particularly in how they can massively amplify what humans can do.
Yeah, you see that already in coding, writing, analysis.
For sure. And he points to the scale too, right?
Yeah, he does. Hundreds of millions of people interacting with tools like ChatGPT every day.
Which means, as he notes, even a really small tweak or improvement.
Or a small mistake.
Exactly. It can have this huge ripple effect, positive or negative, just because so many people are using it.
So the takeoff isn't a Hollywood explosion. It's more like the engine has started, the core science is solved, and it's already integrated at scale.
That's the idea. It's the digital intelligence amplifying us that's taken off.
Right.
Not necessarily, physical robots everywhere yet.
Yeah. Okay, so if we accept that premise, that we're past this sort of invisible threshold, what does he see happening next, like really soon? Because the post gives some, frankly, very specific timelines.
It really does. And they are, let's say, ambitious. He claims that 2025, so this year, has already seen AI agents doing real cognitive work.
Real cognitive work, like complex thinking tasks.
That's the implication. He suggests AI is already capable of tackling things that require significant intellectual effort, and it's dramatically changing fields like software development. AI assistants are becoming almost standard there.
Okay, but then it gets even more, intense. He predicts 2026 next year could bring systems capable of figuring out novel insights.
Right, and that's a critical step, isn't it? Moving beyond just processing or summarizing existing human knowledge.
To actually contributing new knowledge, new scientific discoveries, maybe.
That seems to be what he's suggesting, yeah. A capability for genuine discovery.
And then he goes even further, 2027.
2027, he thinks, could be when we see robots doing actual physical tasks out in the real world.
Wow. Okay, so that would bridge the gap, wouldn't it, between the purely digital intelligence we have now and interaction with the physical environment?
Definitely. So if you map that out, his timeline suggests this potential progression. Advanced cognitive help now, novel insights next year, physical robots the year after.
That's incredibly fast, if it happens like that.
It is, and he does add a nuance. He thinks that while these tools make creation easier for more people, the experts who really learn to leverage them will probably pull even further ahead. It's about amplifying the capable.
Right, not necessarily making everyone an expert overnight, but giving huge leverage to those who are already skilled. Okay, so that's the near term. What about, say, the 2030s? Does the world look completely alien then?
Well, interestingly, he suggests maybe not in the ways you'd immediately think. He proposes that core human experiences,
Yeah.
Family, creativity, playing games, being in nature, might not feel wildly different.
The fundamental stuff stays.
That seems to be the idea. But, and this is the key part, he says in other still very important ways, the 2030s will be wildly different.
Okay, so what makes them wildly different then, if not the core human stuff?
His answer comes down to two things: the expected abundance of intelligence and the abundance of energy.
Intelligence and energy.
Yeah. He sees those two as the fundamental limiters on human progress throughout all of history. Our lack of sheer brain power and affordable, clean physical power has always constrained what we could achieve.
And his argument is, if you remove those limits, if intelligence and energy become super abundant, super cheap,
then, as he puts it, we can theoretically have anything else. Problems that were bottlenecked by thinking power or energy become solvable.
that's a huge claim.
It is. And he has this interesting way of describing how we'll adapt to it. He talks about how wonders become routine and then table stakes.
What does he mean by that?
Well, he gives examples. Like, first, you're amazed AI can write a decent paragraph. Then almost immediately you're asking, okay, when can it write a whole novel?
Right. Or you go from AI helping doctors diagnose diseases
To demanding it find actual cures. The bar just keeps rising instantly. The incredible becomes normal almost as soon as it arrives.
So that's how he sees the singularity goes, not as one big boom, but as this constant rapid normalization of previously impossible things.
Exactly. It's the assimilation of these accelerating capabilities into everyday life.
That makes sense as a description of how tech gets adopted, but how does the acceleration itself happen? How do we get from where we are now to those routine wonders so fast? What drives it?
He points to a few key self-reinforcing loops. One big one is AI directly helping with scientific research. All kinds.
Including AI research itself.
Critically, yes. He suggests that if AI can speed up the discovery process, maybe do a decade's worth of research in a year or even a month, that speeds up everything, including making AI itself better, faster.
He calls that a larval version of recursive self-improvement.
Exactly. It's maybe not Skynet rewriting its own code yet, but it's AI significantly accelerating the human-led process of improving AI.
Okay, what other loops?
Another one is simply the huge economic value being created by AI right now.
Which drives investment.
A massive investment, particularly in building out the necessary infrastructure. You can see it everywhere. With data center construction booming globally, you need that physical base to run bigger, more powerful models.
Right. More compute needed.
And then he looks further out, suggesting robots could eventually automate that entire physical supply chain.
The supply chain for AI itself.
Yeah. From mining the raw materials to making the components, building the factories, even constructing the chip fabs and the data centers. Robots building the infrastructure for more robots and more AI.
And if you automate the building of the infrastructure.
That's how you get to his idea that the cost of intelligence could eventually drop to near the cost of electricity. Becomes incredibly cheap because the means of production are automated and powered by abundant energy.
He gives some numbers too, doesn't he, about current efficiency?
Yeah, just to make it feel more concrete, like a ChatGPT query using about 0.34 watt hours, like an oven for a second or a light bulb for a couple of minutes, and tiny amounts of water.
It makes the potential efficiency seem achievable somehow.
It underlines his view that current bottlenecks, like compute costs, are probably temporary if these loops play out. Intelligence itself could become almost free.
Okay, so we have this picture of incredible acceleration, potential abundance, but he does acknowledge the downsides, the very hard parts. What are the big challenges he flags?
Yeah, he's quite direct about it. He says whole classes of jobs will disappear. He doesn't really hedge on that.
That's a stark warning.
It is. But he sort of balances it with this optimism that the world will get so much richer so fast from all this AI-driven productivity.
That we can afford solutions.
Exactly. That new policy ideas, things like universal basic income or huge retraining initiatives, might actually become financially feasible in a way they just aren't today. The sheer increase in wealth could open up new options for managing the transition.
So he's pretty optimistic about our ability to adapt overall.
He seems to be, yeah. He draws parallels to the Industrial Revolution, massive disruption. But ultimately, people figured out new things to do, living standards rose, expectations changed. He thinks people will figure out new things to do and new things to want.
And he has that interesting point about what makes humans different from machines.
Oh, yeah, that's fascinating. His point that we are fundamentally wired to care about other people. We seek validation, connection, meaning from each other, not from machines, however intelligent they become.
And the analogy he uses about the farmer.
Right. Imagine a subsistence farmer from 1,000 years ago looking at, say, a modern office job. It might seem completely pointless, like a fake job, just pushing papers around, compared to the struggle for survival.
But it feels vital to the person doing it.
Exactly. And he speculates that people 1,000 years from now, in a world of AI abundance, might look back at our jobs and think they seem trivial. But they feel important and meaningful to us. It suggests our definition of meaningful work will adapt.
That's a really powerful way to think about it. But amidst all this potential adaptation and abundance, he does clearly name the biggest risk, the most serious challenge.
Absolutely. He's very clear. The primary challenge is safety and specifically solving the alignment problem.
Which is?
Making sure these increasingly powerful AI systems actually act in ways that align with human values and intentions. Getting them to pursue goals that are genuinely beneficial for humanity in the long run, understanding what we collectively really want, as he puts it.
And he uses misaligned social media as a sort of warning example.
Yeah, a simple case. Feeds optimized for short-term engagement, maybe not long-term well-being. That's a misalignment, even with relatively simple AI. Imagine that kind of problem scaled up to superintelligence.
It raises that huge question, though, doesn't it?
Yeah.
How do we define collective alignment? Who gets to decide what we collectively really want?
Exactly. And how do you translate that into concrete instructions or constraints, the broad bounds he mentions, for an AI that might be vastly more intelligent than us?
What's his proposed approach to managing that risk?
Well, he strongly emphasizes widely distributing access to AI, making it cheap, making it available to everyone, preventing it from being controlled by just a few actors.
Why is that key for safety?
His argument seems to be that societal resilience and adaptation work best when power isn't concentrated. He expresses trust in society's ability to learn, to adapt, maybe even to make mistakes and recover, if decision-making and capability are spread out. If we can somehow harness collective wisdom and give users freedom within agreed-upon safety limits.
So figuring out those limits becomes the crucial conversation.
Absolute paramount, yes.
Okay, so moving towards the end of the post. If intelligence is abundant, cheap, the science is done, what's the new bottleneck in this future?
Well, he talks about the whole AI industry collectively building this kind of brain for the world, a global personalized intelligence network that's super easy for anyone to tap into.
Like having a super consultant on call for everything.
Sort of, yeah. And in that kind of world where the AI can handle the technical execution, the complex calculations, the heavy lifting, the limiting factor shifts.
To what?
According to Altman, it shifts to having good ideas.
Good ideas, seriously.
That's what he says. The bottleneck isn't building the thing anymore. It's figuring out what to build, what problems to solve, what questions are worth asking the AI.
So, the idea guys.
He literally says the idea guys, who often get made fun of in tech for being all concept and no execution,
Are about to have their day in the sun. I remember reading that.
Yeah. It suggests a fundamental shift in where value comes from. Away from just technical skill or execution capability, towards creative vision, insight, judgment, the ability to formulate valuable goals for the AI to achieve.
That would be a massive change in, well, everything. Skills, education, the economy.
Potentially, yes. If the leverage point moves from how to build it to what is worth building.
And how does he imagine this whole massive transition feeling for people living through it? Is it terrifying, exciting, disorienting?
His take is interesting. He suggests that while we're actually in it, the transition toward superintelligence might feel impressive, but manageable.
Manageable, really?
Yeah. Like looking back from the future, it might seem like this incredibly sharp vertical takeoff, a true singularity event. But living through it day by day, it might feel more like a smooth curve.
Just continuous, rapid improvement, but maybe not one single moment of shocking change.
Perhaps.
Yeah.
He used the analogy of trying to predict 2025 back in 2020. The changes since then are actually enormous if you stack them up. But did it feel like a sudden cliff edge day to day? Maybe not for everyone. It felt more like a steady stream of new things, better tools.
That just cumulatively add up to something revolutionary.
Exactly. It's that perspective difference. And his final hope kind of reflects that desired feeling for the transition. He says, may we scale smoothly, exponentially, and uneventfully through superintelligence.
Uneventfully. That's quite a hope for something so potentially transformative.
It is. Smooth and uneventful exponential growth.
Wow. Okay, that really was a deep dive into just one, but very dense perspective from saying we're already past the event horizon.
Yeah, that initial claim is really something.
Through those rapid-fire predictions for the next few years, novel insights, robots.
Which seem incredibly close if he's right.
To that bigger vision of abundant intelligence and energy, basically removing the old limits on what humanity can do.
And crucially, the acknowledgement that the upside, faster science, better quality of life, new wonders is huge, but it comes with these massive challenges.
Right. Solving alignment, ensuring it's distributed safely and fairly, that's presented as absolutely critical work.
Paramount, yeah. You get this sense of immense technological optimism, almost inevitability about the capability.
But paired with a very sober understanding of the societal and safety hurdles we absolutely have to clear. It's quite a balance.
It really is. It paints a picture that's both, incredibly exciting about the potential and also quite grounding about the responsibility involved.
Definitely leaves you with a lot to think about.
Which brings us to a final thought for you, the listener. If this perspective holds any water, if intelligence really does become, as Altman puts it, too cheap to meter, and if the main bottleneck really does shift away from technical capability towards having good ideas, what does that actually imply? What does that mean for the skills that will be most valuable in the coming decades? Or for education? Or even just for how we think about our own contribution and purpose?
What does it mean to have a good idea when execution is easy? That's something to definitely mull over after this deep dive.